Hey, Algebra 1, we're back with the last section of section 12.9. We're going to talk about a couple of a rate problem. So transportation. So this problem refers to some information that we got in the beginning of the chapter, and we'll go back to that in a moment. It says, refer to the application at the beginning of the lesson. The yellow line runs between Huntington and Mount Vernon Square. Suppose that one train leaves Mount Vernon Square at noon and arrives at Huntington 24 minutes later, and a second train leaves Huntington at noon and arrives at Vernon Square 28 minutes later. At what time do the two trains pass each other? One of the things that we would need to know is the distance, and we see that they're on the yellow line, and we're talking about the trains in metropolitan Washington, D.C., but on the yellow line, the distance between the two stops would be 9.46 miles. So let's go back and add that information to our problem. So D is equal to 9.46 miles. And let's go through what we know. We know that rate times time is equal to distance, right? So that's going to be the same for both of these situations. The rate times time is equal to distance. And what we need to figure out is when these two vehicles traveling in opposite directions, starting off at the same time, meet each other. So let's figure out how we can do that. So the first thing we're going to need to is to calculate the rate for each of these situations. So the rate for the rate with miles per minute for the yellow truck, or the not truck, these do look like trucks, the yellow train, or train A, would be the distance, which we know to be 9.46 miles, over the time. And we know that the time it took for this train to make its run would be 24 minutes. And similarly, we'll do the same thing over here, 9.46 miles per minute, but that would be 28 minutes it took to make that. So we can reduce it and figure out that their individual rates can be written like this. And I know I really didn't reduce anything. I was going to go through some decimal drama, but I decided not to at the last moment. Let's go ahead and look at how we can consider the relationship here. So we know at whatever speed this train is traveling, right, which is 9.46 miles per 24 minutes, and whatever rate this train is traveling, there's a time when they cross each other. And that time will be the same for both of them because they both started off at the same time, right? So this is I'm going to call it the red T that we're looking for. We want to know how long that took. Now, remember what we said. We said that rate times time is equal to distance. So we know that the rate of train A times this magical red T that we're looking for, the time of crossing, plus the rate of this train B times the same time would be the distance that they would cover. They wouldn't cover the whole distance, but they would cover part of the distance to make the whole distance, meaning whatever the distance they cover thus far, so this is call it distance 1 and distance 2, whatever distance train A covers plus the distance train B covers has to equal the entire distance. So remember, rate times time equals distance, right? So let's find out what distance 1 would be. It would be 9.4, I'm going to write it down below. It would be 9.46 divided by 24 times T. I'm going to use this red T because that's the one we're talking about. Times T would be this distance 1. That's my D1. I'm going to add to that my D2, which is going to be, again, 9.46 over 28 times T. That's the special time we're concerned about. So that's distance 2. What did we just say distance 1 plus distance 2 is going to equal? The entire distance, right? So when I add those up, it's going to be the entire distance, 9.46. And so now this is where I get my equation, and this is what we have to work on solving. So how would we solve such a thing? Well, we would do what we usually do. We get a common denominator and we keep it moving. That's one way. We could also pull out our calculators and try to see if we could simplify it. All ways are on the table when you're dealing with problems that are a little bit more challenging. So with the calculator, we found the common denominator to be 168, and we modified the numerators accordingly. And then so we end up with this. We know that we don't need to worry about that denominator anymore. And so now it's a matter of solving that equation. We're going to join like terms together. That means joining those T terms. We get 122.98 T when you join these guys together. is equal to 1,589.26. We're going to divide both sides, as you know, and we end up with t is equal to 12.92. What does that refer to, though? That's how many minutes it took for them to reach. That's our, sorry about that. That's our critical, do it again. I can use a computer. That's our critical t value here, 12.92 minutes. And so with that, at what time do the two trains pass each other? And that's at basically 12:13, right? 12:13 p.m. because that's the 12.92 minutes that goes into that 13. Make sense? Or 12, 12.9. All right. So with that in mind, we're going to move on to the next problem. So sometimes we can have these situations where there is no solution. Let me get rid of this. This is making me annoyed. Okay, so sometimes we can have these situations where there is no solution. And what you would do in a situation like that, let me get myself straightened out. What you do in a situation like that is you're going to process exactly the same way, but generally what you find out is that something down here caused us not to have a solution. So we know our common denominator is going to be x minus 1 because we have that here, and then we know we're going to get that there. So x minus 1 is going to imply that x cannot equal the number 1, right? So if I keep that little bit of information in mind, I'm going to be able to knock out this problem easily. So 3x over x minus 1 plus 6x minus 9 over x minus 1 is equal to 6 times x minus 1 over x minus 1. Now that I've talked about what x can't be, I can get rid of that. And so I got 3x plus 6x minus 9 is equal to 6x minus 6. Joining some like terms together, I get 9x minus 9 is equal to 6x minus 6. Moving things around, I'm going to subtract my 6x to get 3x on the left side here, and then on the right side I'm going to end up getting a positive 3, and I get that x is equal to 1. And before I box it off, I see that I got that conflict. So I know that x does not equal 1, and we have no solution because the only solution I came up with was an extraneous root or a kind of an extraneous solution. And so we have no solution. All right, so over here, this problem is interesting because it looks kind of like it should be, looks kind of like we would have to have a very complicated denominator, but we don't. Here's what we'll do in a situation like this, and I do want you to pay attention. The fact of the matter is I can look at n squared minus 1 and see that I can factor it to n plus 1 times n minus 1. And before I take this as a factor, this is a factor, and this is 3 separate factors, I know I can look at this. If I were to factor out a negative 1, I would get n minus 1 with a negative 1 on the outside. I can compensate for that by multiplying the top and bottom by negative 1 in a way, in order for me to end up with an equivalent fraction of negative 2n over n minus 1. This is the magic of negative 1 we've talked about, and we've looked at it before. If you are having trouble understanding this little trick, let's talk about it again. So what I have now, I'm rewriting the entire problem with the factor form here. What I have here is a clearer sense of what my common denominator needs to be, and it's got to be n minus 1, n plus 1. So now with that, I make sure everything has that same denominator, and then I compensate by redoing the numerators accordingly. So this is 2n times n plus 1, and then this is going to remain the same because this came with all the stuff needed to make our common denominator. And then here we have n plus 1 times n minus 1 over the same down here. All right, so you know how we do it. We decide that n cannot equal plus or minus 1 given the denominator, and then we get rid of the denominator. Now we're going to solve this like we do any problem, distribute through. Negative 2n squared minus 2n, notice that negative got distributed through, plus n plus 3 is equal to, and this breaks down to n squared minus 1 as per how we saw it before. Joining like terms together, I think I'm going to move everything over to the right side because I can see that my quadratic term or the square term does not disappear. So I'm going to move it over to the other side. So this is going to become 3n squared. These guys come together to give me a negative n, but when I move it over to the other side, I get a positive n. This positive 3 moves over here to make a minus 4, and that's equal to 0. So my hope now is that I can factor this. And so I know that I can only factor 3n. There's a number of ways we can multiply the 3 times the 4 and do the thing that we've done in the past. I'm just going to illustrate a different way. So I can say, oh, well, I know that 3n squared can only be broken down as 3n and 1n. And 4 is the thing that a negative 4 means that my signs have to be different. So 1 has to be negative, whereas 1 has to be positive. I'm not sure, but I have to figure out what values to put where in order to multiply and get my answer. So I know that 4 minus 3 is going to give me 1. So I'm feeling like I'm going to put a 4 here and a 1 here to make that 4. And then, so it's a little bit of guess and check. I know some of you are like, we should have just did it the other way, lady. And that's okay too. When I multiply these guys together, I get negative 4n. When I multiply these guys together, I get a positive 3n, which doesn't give me the negative n, but that's an easy fix. I can just put a plus sign here and then change this to a subtraction sign. I lost part of my problem over here. And I'm good to go. So now I feel confident in my factor form here. Everything meets the criteria that I need. You probably factor this better and different. That's okay. And then so what I get from this implies that n is equal to either negative 4 over 3 or n is equal to 1. And we already had the caveat that n cannot equal 1, so this is an extraneous root. And then we end up with negative 4/3 as our only answer for n in this situation. Thank you for coming back with me and checking out this video, this second video to 12-9. I really don't love doing 2 videos, but I just felt like it was necessary. Let me know if there's anything that we need to talk about, any questions that you have. I want to talk to you, seriously. Let's get together and see what we can do to make sure things make sense. I will talk to you guys later. Please take care and have a very, very good day. Bye-bye.